How about now? Oh, yeah. Yeah, I unplugged my microphone and I plugged it into a different spot to see if that would help with the awful, awful noises. And so it like didn't recognize it the same. But yeah, I can see that it's working now, and I could see that it was not working before. Okay. Anyway, yeah, that's how you would actually do that problem, like the real way. Next, complex numbers. Ooh, I haven't seen complex numbers on these tests for a while. So I guess you got to know what these are, or you can think about them. Actually, yeah, I did know you have to know what I squared is. We talked about that actually just yesterday. I don't know what I'm talking about saying. We haven't done I stuff in a while. So I is the square root of negative 1, right? So then what is I squared? Well, if we square a square root, they cancel out. So I squared is negative 1. But then they also want us to do I to the fourth, so let's think, what is I to the fourth? Well, isn't I to the fourth the same as I squared times I squared? And what is I squared? Negative 1. So what's negative 1 times negative 1? Positive 1. So I to the fourth is positive 1. So then what do we actually have here? We have 16 times positive 1. We have negative 8 times negative 1 plus 4. So what is that? 12 plus 16? 28. Very good. Okay. The value above shows two pairs of values for the linear function. The function can be written in slope-intercept form. What is the value of a plus b? Okay. So here's what we're going to do. First off, we're just going to find the slope. And then we're going to count the pattern back to find the y-intercept instead of actually trying to write the equation. So we'll say the y went down by 5 when the x goes down by negative 4. Or goes down by 4. So the slope is 5/4. So a is 5/4. And then we're just going to count the pattern back. This, honestly, I've done this on quite a few problems, even specifically like when they're on this table and in the free response section. If you want to call this free response, and the grid in response, is that you've got to just count back from the table is the best way to do it. You continue the pattern. You say, so we go x is 4 because it's going down by 4, and then x is 0. And on this side, you see it's going down by 5 every time. So 12 minus 5 is 7. 7 minus 5 is 2. And see how that's the y-intercept, because that's when x equals 0. So b is 2, so a plus b is 5/4 plus 2, which is 13/4. Which is the valid answer. What is that as a decimal? Not that that really matters. 3.25. So both of those would be valid answers. Okay. So next, what are segments OA and OB are radii of the semicircle? Got it. Arc AB has a length of 3 pi. And OA is 5. Okay, so the radius is 5. What is the value of x? Got it. So this length here is 3 pi. So we're talking about like sectors of a circle. So we're talking about what is the circumference of an entire circle. They do give you this formula, but you should know it. It's 2 pi r. So if we're talking about, well, yeah, I'll just base it on the whole circle. Because the idea is 2 pi r is the radius of the whole circle. But then if we multiply it, by the fraction of the circle we want, i.e. x, because that's the angle we care about, out of the entire 360 degrees of the circle. So that's like the fraction of the circle we care about, multiplied by the entire circumference, will get us the circumference of the arc that we care about, which in this case is 3 pi. And then they also tell us right here, OA, the radius, is 5. So we have that one as well. And now we just have to solve for x. And look how pleasant the numbers actually are. Because the pi's cancel. This is 2 times 5, which is 10. So that's going to cancel out with this 0. And so you're just left with x over 36 equals 3. So you've got to do 36 times 3. Multiply both sides by 36. So 30 times 3 is 90. 6 times 3 is 18. 90 plus 18. X is 108. Very good. 23 minutes for that section. That's some pretty solid timing. How much minutes are you allowed for it? Ooh, 25. Okay, so I was right on time. I was right on time. But I was also explaining stuff. Taking longer than I would personally. So let's check answers. We gotta check answers. It's good to do that in between. Make sure we get them right. Math lab. I guess I could pause the recording. Maybe I will for the second section, but it's too late for that now. And we're going to 2018. And we're going to the April school day test. This is just on here, isn't it? But this way I can pull up the answers more specifically. So here we go. We got number 1 is C. And then we're looking at B. And then A and then C. No way. I got number 4 wrong already. No. No, I didn't get number 4 wrong. I wrote D on the outside when I very obviously circled C. I remember that because remember we did we found that C worked and then I checked D and so I had D on the mind when I was writing the answer on the outside. So no, we got that right. We chose C. That was correct. We continue the rightness with number 5 being C and then being A and then also being C, hopefully. Yes. And then being D. Let's notice when we find the question that we were really close to getting wrong. So 9 is C, 10. Okay, I got this one wrong. I got number 10 wrong. How did I get number 10 wrong? Did I screw up the math trying to go faster or something? So I said we had 8x. Oh my gosh. I totally missed the fact that you have to distribute to here too. You have another minus 2x here. I totally missed that. Which means this should actually be a 6. Right? Because it's 8x minus 2x. So then we should have 6 minus 2c equals 1. So we should be subtracting. So this should be 5. It should be 5 halves. Oh no. Oh no. I totally missed that fact. I can't believe I missed that. That's not good. That's not good. Yeah, I might have missed out on the actual test too, to be honest. Alright, we got one wrong, not the end of the world. I think we had 2 in a row that we got perfect, so I'll take it. So 11 is D, 12 is C, 13 is A, 14 is the one I almost got wrong, but we got it right with D, and 15 we also got right with D. And then we were looking at 6, we were looking at 2, we were looking at 28, I remember that one. We were looking at 3.25 and 108. Very cool. So we got one wrong. So let's redo that real quick with a full solution of what it should have actually been. So it's the same idea. Everything I said was correct. The only thing that I missed out on was the fact that we're distributing a 2x. I guess I was thinking more of we were distributing a 2c. But no, we were distributing the x. So not only will this be 2xc, but this will also be minus 2x. And that needs to equal x. So we can do the exact same thing where we divide everything by x and cancel out the x. But then we'll have this negative 2 to combine with the 8. So we'll end with 6 minus 2c equals 1. So then we're subtracting 6 from both sides to get negative 5 and dividing by negative 2 to get that c equals 5 halves. Alright, slight mistakes. Slight mistakes. Okay, on to the second half. They do give us these formulas. I never refer to them, I guess just because I know them, though. That's supposed to be a multiplication sign? Anyway, I'll be right back. You never gave me your stats problem. Here, we can pause this. So let's continue. No calculator section. As always, we'll use the calculator when needed, but seldomly. So 6 times 2, don't need the calculator for that, equals 36. 36 divided by 12, don't need the calculator for that. 4 times 3 is 12, minus 2 is 10. Yep. Another good way to do that it's like fun to do this, but it's really not that quick, especially in this, because doing it the real way is quick enough. But look at how you could divide both sides by 6 and get that 2k equals 6. And then we multiply both sides by 2 to get that 4k equals 12. And then we subtract 2 from both sides to get that 4k minus 2 equals 10. So that's super legit. You see, you get the same answer. And like people don't realize you can do that. All we're doing is we're doing the same thing to both sides of the equation, which is always a legal move. Even if you're not doing it for like the reasons of getting k by itself, that's always a legal move. All right, get into stats. I guess there was no stats on the last section. So which of the following is true based on this data? The bus had the most riders on Tuesday. So we just got to go through one by one. Okay. So that's not true because Friday had more. Each day, Tuesday through Sunday, the number of riders on the bus was greater than the previous day. So they're saying Tuesday was also greater than the previous day, but no, Wednesday was not greater than the previous day. So that's not right. Each day, Tuesday through Sunday, the number of riders was less than the previous day. Well, that's not right because Tuesday was greater than the previous day. So it must be D. The 2 days with the fewest numbers were Saturday and Sunday. Well, that just makes sense because no one's going to work. Yeah, exactly. Definitely. Okay, 2D. A physician prescribes a treatment in which a patient takes 2 teaspoons of medication every 6 hours for 5 days. According to the prescription, how many teaspoons of the medication should the patient take in a 24-hour period? Are they throwing a +1 error on here for us? Ooh. So it's okay. So we're actually gonna count. So he's gonna take how many doses is he gonna take is the question. Each dose is 2 teaspoons. We'll do that at the end. How many doses is he gonna have? So he's gonna have a dose at midnight. He's gonna have a dose at 6 a.m. He's gonna have a dose at noon. He's gonna have a dose at 6 p.m. And so I guess his next dose at 12 a.m. is not part of this, right? Because that's not actually within the same 24-hour period. So I guess it's not as scary as I thought it was going to be. He's just taking 4 doses, because that's just 24 divided by 6, times 2 teaspoons, 8 total teaspoons. Okay. So it wasn't as scary as I thought it would be. That's like a common problem, like specifically with medication. The idea that like you're going to take medication right away, so you're going to need more doses than you might think. 1 extra dose to take right away. Anyway, 100 Park District members will be selected to participate in a survey about selecting a new Park District coordinator. Which of the following methods of choosing the 100 members would result in a random sample? So we just want a total random sample. Obtain a numbered list of all Park District members. Use a random number generator to select 100 members from the list. Give the survey to those 100 members. I mean, that seems as pretty straightforward as you can get, right? So yeah, you'd like B. So let's look and see why the other ones are wrong. So B is wrong because you're just choosing the first alphabetically. So that's not necessarily random. I mean, for one, you're going to be like everybody in the Addams family. You're going to sample, right? So you're going to get a whole bunch of the same families and then just totally exclude some families. So that's no good. Tell all Park District members that volunteers are needed to take the survey. So having people volunteer for a survey is always a problem because people that volunteer for a survey are the angry people, generally, or the people with extreme opinions, you would say. So you're not going to get just like the average opinion, which is what we see on Twitter, too. We see all the angry people on Twitter. All the people with the good opinions don't say anything because they're just like content. But all the angry people, they're the ones that talk. So that's not going to work. Obtain a list of all Park District members who are attending an upcoming event. Same thing. Exact same thing. If you're coming to an event, you have a more positive favor of it. So that's no good. A is definitely the correct choice. I feel like the questions that you have no choice but to read every answer, I really think it is more often A. Like we've seen that twice today, actually, right? We started to look at every single answer choice and just the first one worked. I feel like that happens a lot. All right. So this one, we don't have to look at every single answer choice. We just have to distribute. So you might think that like you can do some like sneaky stuff right now, but that's you maybe, but that's not what we really want to do. We just want to distribute. It's just nice and easy. Nothing to distribute here, and then we'll just combine like terms, and actually those are just canceling. These, remember, you definitely cannot combine those because x cubed and x squared are totally different things. It's apples and oranges, so it's C. Yeah, easy enough. This one. X plus 3 equals 2x minus 2. What is the value of x minus 4? So, I mean, I would try to use the trick I talked about last time, but as soon as we subtract x from both sides and add 2 to both sides, we just get x equals 5. So then what is x minus 4? Just gotta subtract 4 from it. You just get 1. Easy enough. Notice we've had really no need at all to whip out a calculator yet. So the functions f and g are those. For what value of x does f of x minus g of x equal 4? So these questions are kind of different than what I've seen before, but they're all stuff you should do. I mean, here you just say, what is f of x? F of x is 4x. What is g of x? X squared. So f of x, 4x, minus g of x, x squared, equals 4. And now we just got to solve for x. So it's a quadratic. We should move everything to the same side. I would think about moving everything to the right because we want the x squared to be positive. So positive x squared minus 4x, this is still a plus 4, equals 0. And so then we can just factor. X minus 2, x minus 2, x equals 2. Very cool. You could use your calculator to solve this, but that's going to take you longer than just factoring it, hopefully. All right, this is another one. Maybe you just want to get out a calculator, but it's quicker to not, to be honest. So the function g of x is defined like that. So you plug in negative 30, what happens? Well, you can do some canceling. So you're going to cancel, just leave this as a negative 10. So you have negative 20 plus 3, which is negative 17. See? All right, so now we got a scatter plot. Which of the following is the closest to the difference between the actual number of home runs and number of predicted by the line of best fit home runs in 2003? Nice, they made it perfect for us. So remember, the line is the predicted value, and the dot is the actual value. And they don't talk about like one minus the other, they're just talking about the difference. So we just got to look about how far away are these. So what is one box? 500? So I'd say it's about 700 different. Yeah, 750. Yeah, 850. 850 would be more than half of this, right? That's what you're doing a lot when you estimate. You go, is it more than half or less than half? And this is less than half, so it has to be on the 750 side. Although I guess 750 is exactly half. But then you also guess this is a little lower than the line, right? So that makes sense. Okay. Yeah. So here, which of the following, or between which two consecutive months shown, did the average price of 1 metric ton of oranges decrease the most? So decrease the most, you think about slope, right? Because again, slope is rate of change. We're looking for the one that decreased the most, so the highest rate of change downward. So which one has the steepest negative slope? I would say right here, just by looking at it, from June to July. The summer orange season? I don't know, it's definitely an orange consuming season. Which of the following is closest to the median price in dollars of the 7 recorded price? The 7 recorded prices of one. So just what's the median of these 7 prices? So we're looking for the one in the middle. I suppose we can actually probably do that with the graph too. Yeah, so look, you go, here are the 3 high prices, here are the 3 low prices, here's the middle price. Wait, hang on. No. Okay. Yeah, so what's the median? The median is this 809 right here. They're actually a little below 809, so 808. Yeah, the median is the middle. In 2014, the average price of 1 metric ton of oranges decreased by 2.36%. from January to February. Not shown. Which of the following is closest to the price of 1 metric ton? All right, so we might whip out the calculator for this one. So anytime there's a percent, so here's the mistake people are going to make. They're going to say, well, if it was 2.36% decrease from January to February, that means from February to January is a 2.36% increase. But no, that's not at all how percents work. You've got to set up, or I would say you should set up the equation. You should go the January price times the 1 minus 0.0236. So that's 2.36%. So that's your percent change went down by that. So January multiplied by that gets you the February number. So then if we want to solve for the January number, we're going to divide both sides by that whole minus thing. So we're going to take the February number, which I guess we got to estimate. That's definitely like right in the middle. So it's like what? 70? 770? 769? We'll go 769. 69 is a nice number. So we'll go February is 769 divided by all of that. And then we'll just have to estimate once we get that number. 1 minus 0.0236. About 787. How's that look? 790? I like it. It's definitely not 770 because that was our estimate here. And it's more than that, but it's not that much more than that. So yeah, I definitely like C. So you've got to set up the equation. You've got to set up the equation. 830 is probably what you get. We can see. So if you do the 770 times that percent increase. Oh, that gets you 788. So is it just really close? I mean, it must be really close. Yeah, so I guess either way you do it here, you still get it right. I like 790, although it does make me less confident in my answer. But no, that's got to be 790. It's just that this is like such a small decrease that it doesn't make a big difference. All right, here we go. Two-way tables. I feel like I haven't done a two-way table in a while. We had a similar idea of a two-way table yesterday. They just didn't give us a two-way table. So here, if one of the houses is selected at random, okay, so just one of the houses in general, what is the probability that it will be a single-story house with a slate roof? So that's always the first question, is what are we choosing out of? Because a lot of times they'll say, like, of the single-story houses or, like, of the slate roof houses. But no, here they're just saying one of the houses. So they're choosing out of just the total amount of houses here. So this is out of 48. And what do we want? Slate roof, single story. So we want 4 of them. That's really all there is to it. 4 out of 48. Is that an answer? That is an answer. We don't even need to simplify. Sweet. Sweet, sweet, sweet. All right, talking about washing machines. The load capacity of a certain washing machine is 12 pounds. What is the approximate load capacity of the same washing machine in kilograms? All right, just a little quick dimensional analysis. Well, NumWorks will also do that on its just totally by its own. We could take a look at that. I imagine other calculators do. But also, it's very slow. That's not the quick way to do it. Because, like, you have to put the arrow there. Then you have to come in here. You go length. You go, what am I even talking about length? We're talking about mass. And you say we're going to start with pounds. We're going to go 12 pounds. And we want to put that into, is that shit tons? No, short tons. We want to put that into kilograms. .44. Boom. B. But see how much slower that is. Then we got 12 pounds, and then we're going to multiply. There's 1 kilogram per 2.2 pounds. So then all we're actually doing is 12 divided by 2.2. If you want to be specific, 2.2046. And we get the exact same thing, 5.44. Notice the conversion rate of NumWorks is a little more specific. They got more right on. And I'd have to imagine that NumWorks is going to be more accurate because they'll be able to use more decimals. But of course, same answer. Okay, similar triangles. Look at that line. Whoa, that's weird. Anyway, so they tell us they're similar. How much longer is E? How much longer than segment EF is segment DE? Okay. So, well, it looks like we know they're similar. So this is a whole divided by 4 situation, which means that this hypotenuse is 29 divided by 4. And then this is 21 divided by 4. And then, I mean, it does work out pretty easily, but we could have avoided fractions if we wanted to. Because now, I mean, we would just say, what's the difference? How much longer than segment EF is segment DE? So 29 over 4 minus 21 over 4, which is 8 over 4, which is 2. B. So we could have also noticed, just said like 29 minus 21, that's 8 different. So then when we divide by 4, it'll be 2 different. Same thing. All right, we somehow missed this question. What is the value of x? It's a beautiful thing. When you just add them together, everything cancels out. So that would definitely freak some people out. But the y's and the numbers cancel out, so you just have a 0. So 4x equals 0. That just means that x equals 0. And you could check yourself. It always, it's like just slightly annoyed me. Because like you see how when you go and plug in, it just becomes so obvious. That like, well, so we plug in 0, that means y has to be 4. And then like, yeah, 0 minus 4 is negative 4. It's like it just kind of becomes really obvious when you realize x is 0. Okay, whoa, this is a long one. Ooh, let's talk about standard deviation. Standard deviation doesn't come up very often. So which of the following is true about the standard deviations of the 2 data sets? Wow. Oh, no. So they're already in greatest to least, it seems. Yeah. So standard deviation is just deviation. A high deviation means points are very different. And so when I look at this bottom set and I see that it goes from 22 to 603, whereas this one just goes from 25 to 126, I'm like, yeah, that bottom one is definitely deviating more than the other one. So I would say that set B has a higher standard deviation. So the standard deviation of set B is larger than the standard deviation of set A. Yeah. And we don't need to calculate it. You could calculate it in the NumWorks if you needed to. But you never need to actually calculate the standard deviation on the SAT. You just have to look at this and say, yeah, those second ones definitely are more different than the first ones. And so they deviate more. They gave you room to calculate it all by hand if you wanted to, though. Jeez. Anyway, so the velocity in meters of a falling object on Earth. Is this the SAT? Yeah, this is the SAT. People are taking it Wednesday in 2 days. So this is the version from 4 years ago. I've already done all the other recent versions, so this is the one from 4 years ago. Alright, so yada yada, ignoring the effect of air resistance, the equation is modeled, V equals 9.8t. Okay, I knew that. There's a different linear relationship between time and velocity on Mars, as shown there. So we're trying to get the equation for that. If an object dropped toward the surface of Earth has a velocity of 58.8 meters per second after t seconds, what would be the velocity of the same object dropped toward the surface of Mars after t seconds? Okay. So we're going to start out by finding the time, I think. We're going to say, we know this equation right here. They tell us the velocity is 58.8. And we know that that equals 9.8 times t. So now we know if we want to find t, we should simply just do 58.8 divided by 9. Unfortunately, I can't do that in my head very quick. So we'd get that t, divided by 9.8. That's why I couldn't do it in my head. I was going to say, divide by 9, I should probably be able to do that in my head. But divide by 9.8, that's harder, even though it is an exact 6. So we get that t equals 6. So that's like what we're talking about is 6 seconds in. So what are we going to do then? We want to know what the velocity is 6 seconds in. Well, I would just look at the table, kind of like we did on the other one. I'd say if we added a little intermediate step here, it looks like it's going up by 7.4 every single time. Every single step of 2, every 2 seconds, is going up by 7.4. So then I would just start at this 4.8, and I would add 7.4. And I would try to do that in my head. I think that's what, 22.2? It's a pretty good answer. Yeah. So we could also write this equation. We just didn't need to. I mean, well, what? The equation would just be 7.4t equals v. And then we would say, well, we're saying at t equals 6. So we're doing 7.4 times 6. Wait. Oh, right, because it's 7.4 every 2. So this is not actually 7.4 times t. It's 7.4 divided by 2 times t, which is 3.7. So it should be 3.7 times 6. 22.2. Yeah. So that's why it could even be harder when you write equations. It could be easier to just look at the graph and figure it out. All right. Number 19. In the xy plane, the graph of the line has a slope of 3, and it's parallel to that line. So what do you know about parallel lines? Same slope. So which of the following is the equation of the line K? So it's got to also have a slope of 3. So let's cross these out. And then we know it contains this point. So we could try to write the equation with point slope form, or we just plug in. And it's kind of nice because you plug in 3. You easily see that does not get you 10 in the first equation. And so it's got to be D. Plug in 3. 3 times 3 plus 1, 10. Yes. All right. A certain colony of bacteria began with 1 cell, and the population doubled every 20 minutes. What was the population of the colony after 2 hours? So I would just kind of do it out, maybe. I would say at the beginning you got 1, 20 minutes in you got 2, 40 minutes in you got 4, an hour in you got 8, an hour 20 is 16, an hour 40 is 32, and 2 hours should be 64. Yeah, I like it. Just count it out one by one. Alternatively, you're like, how many sets of 20 minutes is in 2 hours? So 120 divided by 20 is 6. And so you'd say you start with 1, and then you multiply it as you double 6 times. So 1 times 2 to the 6th, 64. Yeah. Ooh, phase diagram. Nice. Okay. The circumference of the Earth is estimated to be 30 kilometers at the equator. Which of the following best represents the diameter in miles? So again, actually, we could just go to the calculator to kilometers to miles. Weird that they have like the same question on the same section. So, but we're just going to do 30 kilometers. And there's 1 kilometer and 0.62137 miles. So we're going to do 40030 times 0.62137. 24873.44. 240. What? All right, let's think harder. Why is that not an answer? Why is that not the answer? Why did it get bigger? It didn't get bigger. It got smaller. Circumference. Oh, approximates the diameter. I didn't read the question. We're looking for the diameter. So what we just found was we found the circumference in kilometers, or in miles. We found the circumference in miles. And then what is the circumference according, like, with the diameter? The circumference, well, it's 2 pi r. Combine these 2 times the radius. That's the diameter. So the diameter, or the circumference is pi times d. So now we know what the circumference is. The circumference is 24,000. If we divide that by pi, we'll get the diameter. So we'll divide that by pi. That'll get us the diameter. Very, very kind of them. Shockingly kind of them to not put 24,000 as an answer choice. Shockingly kind of them to not do that. That would have got so many people. All right, some fun percents. So the budget for a school band was $8,000 in 2010. The budget decreased by 15% from 2010 to 2011. Okay, so we're starting with 8,000. Remember, it's multiplication, so the order doesn't matter. Like, it looks like all the 8,000s are last, but that's fine. So we're going to do 8,000 decreased by 15%. So multiply by 1 minus 0.15 times 0.85. And then increase by 22%. So then multiply by 1 plus 22%. And there we go. And again, remember, order doesn't matter. All we're looking for is those three things multiplied. So we've got the 8,000, we've got the 0.85, and we've got the 122. Right about there. Yep. All right, look at this thing. Let's actually not look at it yet because we just need this. The equation of the boundary line between the Andalusite and the Sulamanite regions is approximated by the equation above. What is the meaning of the t-intercept of this line? Okay, the t-intercept. So they're talking about like the x-intercept then, right? Because the t is in the x spot. So a t-intercept, an x-intercept, is when the y value is equal to 0, which in this case is p. So they're saying when p is equal to 0, that would be the temperature. It's in between Andalite and the other one. So let's read these through form. So I don't like the maximum temperature idea. I like the idea of B, talking about when there's no pressure applied. And that's like the boundary line, right? That's what the whole thing when you talk about phase diagrams, that like if your temperature and pressure is there, you're going to get the kyanite. If your temperature and pressure is here, you're going to get probably like an even mixture between kyanite and andesite. If you're right in the middle, you're going to get all of them. So I think this is the idea. We're talking about the t-intercept is when p equals 0, when there is no pressure. And it's when both of them can form, because it's the boundary. It's when you change it slightly, only one of them are formed, but it's right in the middle, so both of them can form. And yeah, it's not the increase here, because yeah, both of these make it sound like slope, make it sound like a rate. But that's what this number is, not the t-intercept. So yeah, I like B. I definitely like B here. Which of the following regions, following system of equalities, best describes the region where Sulamanite can form? So we look at for Sulamanite, so we're talking about this line right here, and we're talking about this line right here. So I extended them out so I could look at the x-intercepts a little bit. So we're looking for like, well, that's actually really small, 0.05 and 0.6-ish as y-intercepts. I did say 0.05, right? Why are they all looking negative? Why are they all looking negative? Is there a cut? There is a cut. So that's not x equals 0 right there then. That's x equals like 300. Shoot. Okay. So what are we going to do then? We're going to say, didn't they give us one of the equations for this Sulamanite? They did. This is one of the equations for the Sulamanite right here. So we're looking for those numbers just with an inequality. 0.00146. Oh, are you kidding? They rounded it. 0.0015 then. Which that one doesn't have. And then plus 1 point. They changed the numbers again? What? Are you kidding me? That's what that equation is. Weird. Okay. This is just obnoxious. So, oh, you know what? They give us perfect values. So that's what we need. We need to say that for both of these equations, they should intersect right there. So we're going to plug in x equals 500, y equals 0.38. And like that point needs to work for both of the equations here. So let's go 0.0021 times 500 minus 0.67. And then we hope that that's 0.38, which it is. So we know that this top equation is good, which means we probably need it, which means it's probably B. If we plug that into the second one, is that correct? We go negative 0.0015 times 500 plus 1.13 is also 0.38. So that's pretty good. Let's just real quick make sure. So this is saying we're above the line with a negative slope. Is that the case if we go back to our graph? So we look for the line with the negative slope and we want to be above it in the Sulamanite region, which is true. Okay, so I like B. That was kind of a harder problem. If we had better graph paper with more specific numbers, we could have written the equations easier. But that was just part of what made it hard. But you know that both of those lines have to go through that point. So you know the equations have to work. Both of the equations have to go through that point. And then that's a pretty good, I think, dead giveaway that they're going to work. From there, you just need to make sure the shading is right, just to be really careful. So we're looking for points of intersection. So we could probably graph it, but again, without graph paper, that does get really tough. So we probably just want to set this up like a system of equations, especially because they're both equal to y already. So you can pretty simply just set these equal to each other. Go ahead and distribute in the meantime, and combine like terms, of course. And then now we have a quadratic. So now we just have to get everything to the same side. So we have x squared minus 3x minus 10 equals 0. So we're going to get two answers, aren't we? Because then we're going to factor x minus 5, x plus 2. So we get x equals 5 and x equals negative 2. So from there, it looks like x equals 5 is the one we're going for. And then we just got to plug in x equals 5 and see what we get. Of course, choose the easier equation. 2 times 5 plus 4 is 14. And then if you're feeling unconfident and you want to check, you could always plug that into the other equation. You get 2 times 7, which is also 14, which tells you right there that you got it right. So the gas mileage in miles per gallon of a car traveling S miles per hour is modeled by the function below. According to the model, at which speed in miles per hour does the car obtain the greatest gas mileage? Ooh, so we're looking for the maximum of this function. That is a calculator problem. So we could graph it too, but this is definitely going to be easier to just graph in the calculator. So we'll use x instead of s just so the calculator understands it the best. So negative 1 over 24 times x squared plus 4x minus 50. Now let's graph it and we'll see what it gets. Numworks is super good at showing us the important stuff. So you see it adjusts the window automatically. We didn't have to move it to be able to see the whole graph. It knows where the graph is. And it'll even mark the maximum for us, like it should. So they're saying when x equals 40, y equals 45, 46. Oh, and x equals 48, y equals 46. So then we read the question again. At which speed is the miles per gallon does the car obtain its greatest gas mileage? So it obtains the greatest gas mileage when x equals 48. So that's the answer. So of course they put 46, because of course they did, because they were mean on this one. But 46 is the gas mileage. But that's not what they asked for, right? They didn't ask what is the greatest gas mileage. They asked at what speed does the car obtain the greatest gas mileage. So you got to make sure you're answering the right question. As always on the SAT, that's where they get you. All right, are we going to try to just continue the pattern again? Maybe. If it's linear, does it say it's linear? It says it's a line, does it? Let's read the question. Table above shows selected values for the function h, and the xy plane, the graph of y equals h of x is a line, so it is linear. What is the value of h of 8? So yeah, I would just continue the pattern, but we just have to be like correct about the pattern. So I would say here our x goes up by 2 when the y goes up by 4. So we'll say if the x goes up another 2, the y goes up another 4, and if the x goes up another 2, the y goes up another 4. And that would put us at 19. Just continue the pattern. We don't need to write out an entire equation, even though we could. So now the front row of an auditorium has 10 seats. There are 50 rows in total. Front row of an auditorium has 10 seats. There are 50 rows in total. If each row has 2 more seats than the original row before it, which expression gives the total number of seats in the last row? Ooh. So it only has 2 more seats. So for every row, so this is like a sequence, right? It's kind of a hard question. But if you just think about it, it shouldn't be too bad. So it's like in row number 1. So what are we going to do? How many seats do we have? We start off with 10. And then, so that's like our starting amount, right? Well, no, actually, I'm going to say our starting amount is 8. Because we're saying if we have in row 1, we have 10 seats. In row 2, we're going to be adding 12 seats. We're going to add 2 seats. So we're going to have 12. So yeah, this is exactly it, right? So all we want to do is we want to know 50. So here we don't want to continue the pattern, even though we could. We need to write the equation because we're looking at a big number. But look how it's just going to be a linear equation. For every next row, we're going to add 2 more seats. And that's literally just the slope. So the entire equation here is 2 times the row number plus 8. You'll see how like when we plug in row 0, that would have 8 seats, but we don't actually have a row 0. We have a row 1 with 10 seats, a row 2, 2 times 2 plus 8, 12 with 12 seats. So that's our equation. Now we just need to plug in 50 because we're looking in row 50. So the answer is 2 times 50 plus 8. Now they might have written it differently than that. Yeah, see, they hit up the 50 minus 1, it looks like. But so if we combine these, 2 times 50 is 100, plus 8 is 108. So we could definitely say that if we're looking to get 108 up here. So I think if we did 2 times 49, that is 98. And then we add 10 to it, that is 108. Equals 108. So since that expression equals 108, that's got to be the right answer. You could glance through the rest of these and see that they're not 108. That's 110. This is 50 times 12. That's 600. This is 10 plus 2 to the 50th. That's massive. So, A. Yeah. So that's the, yeah, you just got to think about it. So here, the ecologist selected a random sample of 30 prairie dogs from a colony and found that the mean mass of the prairie dogs was 0.94 kilograms with a margin of error of 0.12. Is that 0.12 on both sides or 0.12 in general? Probably on both sides. So it's probably plus or minus 0.06. It's also kind of nice because I would put it right at 1. Oh, that's actually what the question is asking. Oh, but then look, they were actually very kind here. They used the same numbers for all of them. So yeah, the margin of error is 0.12. That means it's 0.06 on each side. So that's where they're getting... Oh, hang on. No. That's not at all what they're doing, actually. They're saying that it's 0.12 on both sides. I mean, it doesn't matter what you consider margin of error. So they're saying the margin of error means that it's plus or minus 0.12. That would have been clearer if they would have said that. So all prairie dogs in the sample have a mass of that. No. Margin of error just means like, yeah, they might be wrong. They're not totally sure about their data because anytime you take a sample, you can never be sure that that sample represents the entire colony perfectly. So that's all margin of error is. It's not guaranteeing. Now, most prairie dogs, see, no, it's not even guaranteeing that. They could all be out of that. All they're saying is the average is in between those. The average is most likely in between those. Any mass between that is a plausible value for the mean mass. Yeah, that's exactly what they're saying. They're saying the mean is in between there. I mean, they could have, like, this is not likely for, like, this scenario, but it could be that half of the prairie dogs weighed 0.5, the other half weighed 1.5. And so that's why they're getting their average of about 1. And then, but in reality, none of them are actually close to that value. They're all far away from that value. Like, that's a possibility when you take a sample. So we can't be making any guarantees like A and B. All we can be saying is that the mean is between those values. Now, what's the difference between C and D? Let's actually look word by word. Oh, only one word different. Sample and colony. So yeah, so we know the mean of the sample. They tell us that directly, actually, right? The mean of the sample is 0.94. That's not in question. The mean of your sample is never in question. You can calculate the mean of your sample. What's in question is the mean of the colony, and that's always in question because you never know that exactly. That's why there's a margin of error. So what we're talking about here with our margin of error is that any mass between those two values is reasonable for the colony. We use the mean of the sample to calculate that. We know the mean of the sample. We don't know the mean of the colony. Got it? Got it. All right, a poster has an area of 432 square inches. That's a familiar number. The length x in inches of the poster was 6 inches longer than the width of the poster. Okay, so let's sketch it out real quick. And then we want to find the dimensions as they're finding like the area and stuff. Okay, so we know the... Also, width and length are interchangeable, so you don't even need to think that hard. You can just write something like this. Like, we know that'll work out, but we could be better. We could say, so the length is 6 inches longer than the width. Oh, yeah. So we did that correctly. Because you got the width, the length, got to add 6 to the width, because it's 6 longer. So the area is 432. So that's just what we're doing. We're doing w times w plus 6, or it looks like they're using x. So x squared plus 6x equals 432. And they don't need us to solve it. I guess probably because if they did, we could just type it into the calculator to solve it. That's what we get. Let's actually do that real quick. I want to make a quick little point out here when we get this answer. I hope the answer looks like how I expected it to look. So let's come up here. Let's change this equation. So we'll just type in this quadratic that we just answered and see what it gives us for our solution. So we get x squared plus 6x equals 432. Syntax error. Oh, I used the multiplication sign instead of an x. Okay, so there's our equation. We want to solve the equation. So we get that x equals negative 24 and x equals 18. So notice, of course, x cannot equal negative 24, right? Because we can't have negative 24, or in this case, I guess, negative 18. We can't have negative values as lengths. So we only choose the positive answer. But also notice, interestingly, that like when you do, you get negative 18 and negative 24, whereas the actual answers are 18 and positive 24. Switched, but different signs. So that's, I don't know, it's kind of interesting. So you still get two answers, you just have to reject one because you can't have negative values as lengths. All right, on to finish out. Whoa, this is an interesting one. This is a very interesting one. So, because we're going to get two answers for x and y, right? So then there's going to be 4 potentially different possible answers for the absolute value of x times y. Well, let's do it. So let's solve for x. So when you split up the absolute value, you've just got the negative version and you've got the positive version. We solve both of them. Here we get x equals negative 4. No, here we get x equals negative 4. Here we get x equals 1. So those are the two possible values for x. Try to do the same thing for y. So we'll go 3y minus 3 equals 6. 3y minus 3 equals negative 6. We'll go y equals 3. We'll go y equals negative 1. Okay. So what are all the different possibilities? Well, we've got... Oh, we only need one of them. Right. So this is not a multiple choice. This is a free response. So you can just pick whichever ones you want. So then you go, okay, let's go 3 times negative 4. Absolute value of that is 12. And so the other possible one should be 3 times 1 is 3. 4 times 1 is 4. 1 times 1 is 1. 1, 3, 4, or 12 should all be answers. You just pick one of them. All right. What is the value of n? In year 4, the difference between the actual revenue and the predicted revenue is N million dollars in year 4. So we already had a problem just like this. We go, the predicted value is 50. The actual value is 55. So then it's 5. I mean, that is right in the middle, right? Yeah, definitely. I wonder if they pick it, if they allow like 4 or 6. I feel like they should. But that is like right in the middle. So that's definitely 5. Just what's the difference? All right, fun little geometry problem. The figure above is a floor plan drawn by an architect for a small concert hall. The stage has a depth. What's the stage? A triangle? It's a weird shaped stage. The stage has a depth of 8 meters and 2 walls each of 10 meters. So it's a 45, 45, 90. No, because we don't know that this top angle is a 90. They don't say that. If the seating portion of the hall has an area of 180 square meters, what is the value of x? Got it. So, oh, we have 3, 4, 5s. Because they are kind enough to point out this right triangle for us. And then we should see that it's a 3, 4, 5, because this is 2 times 5, and this is 2 times 4, which means that this side is 2 times 3, 6, which means that all the way across, because this is also 6, so all the way across is 12. And if we know the seating area has an area of 180, so that means if we wanted to find this x, which is exactly what we want to find, 12 times x is 180. So we're looking at 180 divided by 12. So of course you could whip out a calculator, but I would just cancel a 6 to see that it's 30 over 2, to see that it's 15. Yeah. Few more? Oh, two more pages. Ooh, pretty. Excited for that one. Jacob bought two types of pins. Blue pins that cost 66 each and red pins that cost D times as much as blue pins. So this is an interesting little system of equations problem then. So red pins are D times as much as a blue pen. Let me rewrite that. 0.6 D. So R is 0.6 D. If the cost of 3 blue pens, which are 66 each, so $1.80, 66 times 3, plus 6 red pens, 6 times 0.6 D, 3.6 D, is 1080. What is the value of D? Right, so now we just got this nice little equation to solve. And it's pretty easy because the 80 cents even cancel, right? So we get 9. So 3.6 D equals 9. So we got to do 9 divided by 3.6. Which again, of course, we could calculator. But I'll go that that's 90 over 36. And then I'd probably cancel out a 6. Because that's 15 over 6. And then cancel out a 3. So that's 5 halves. 2.5. Yeah, you just got to set up your equations. Got it? All right. George took a non-stop flight from Dallas to LA. The total flight distance was 1,200 miles. That's far. The plane flew at a speed of 460 miles per hour for the first 75 minutes and at a speed of 439 miles per hour for the remainder of the flight. Why'd they slow down? The nearest minute for how many minutes did the plane fly at a speed of 439 miles per hour? Oh, okay. So we go for 75 minutes, which we actually don't want that in minutes, we want that in hours. So then we'll multiply by 60 minutes per hour. So now we're in hours, and we're going to find the distance that they traveled because they went 460 miles per hour. So now the hours cancel. So now we found the total distance that they've gone. Should we go ahead and put that on the calculator? So in that first 75 minutes, they went 75 times 460 divided by 60 miles. So they covered 575 miles in 75 minutes, which makes sense, I guess. It should be a little more than 460 since that's how much you go in an hour. So they've already covered 575. So then we're going to take the total distance, 1233, and we're going to subtract that 575 to say they've got a total of 658 miles left. And they're going to be going 439 miles per hour. And then we want it back in minutes. So then we got to do that there's 1 hour in 60 minutes. So then we've canceled out the miles to put it in hours. We've canceled out the hours. So now we know how many minutes it'll take to travel that final distance at that speed. So we'll do that answer. Does that does dot do that? No. So that answer times 60 divided by the 439. And then they want us to the nearest minute. So it looks like 90 minutes. An hour and a half left. Makes sense. They're less than halfway there. Going a little slower. Yeah. Okay. Maybe it's California emission rules. Make you slow down once you get there, but obviously in Texas they don't care about that stuff. That's why they had to slow down. All right. An arc of a circle measures 2.4 radians. Right, so we did the length of an arc earlier, like the circumference of an arc. Now we're talking about the measure of an arc. So when we talk about the measure of an arc, it means it's like we have something like this, and they're saying that this angle is 2.4 radians. Not to scale, of course. And then when they're talking about the arc, they're talking about like this arc here. So what do they want? To the nearest degree, what is the measure in degrees of this arc? Oh, so this is just radians to degrees. So this conversion is on the front of the test. It's also probably in numworks. Almost definitely in numworks. But you just do it by hand. You go, if we have 2.4 radians, we need to know that there are pi radians in 180 degrees. So now we've canceled out the radians. We're in degrees. We simply need to do 2.4 times 180 divided by pi. And it should be 137.5. How do they want this answer? To the nearest degree? Are you kidding? What? Did I do something wrong? 2.4 radians? 2.4 radians is 180 degrees in pi radians. I mean, the nearest degree is 138. I'm worried we got that wrong. We definitely did that right. So I don't know why they toss us in the middle of a decimal there. That's weird. Has there been any trig on this? I don't think so. Yeah, there's not down here either. Alright. Carrie, a packaging engineer, is designing a container to hold 12 drinking glasses shaped as regular octagonal prisms. Her initial sketch on the top view of the base of the container is shown below. Yeah, so every white thing is a glass, drinking glass. It's an octagon. The length and width of the container base of the initial sketch were doubled. How many more glasses could the original new container contain? Wow, okay. So this is, I talk about this all the time. If you're going to double the length of something, what's that going to do to the area? If you multiply the length of stuff by 2, that means you multiply the area by 4. And what is area? But how many things can fit in the area? The word's in there. So right now it looks like we got 3 by 4. It looks like we got 12 glasses. So if we double the length and the width, we're going to fit 12 times 4 glasses. We're going to fit 48 glasses. And I could even show you just with a quick copy and paste. Well, this is going to be a little dirty, but if we double the length, oh yeah, I'd have to crop that and stuff. Although, maybe that's worth it. So we go crop, we go bada bing and bada boom. And see how now, like, that's doubling the height, right? And then to double the width, I would need to do this, of course, right? And to finish it out, I would need to do that. And now if we counted, we'd be like, we got 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6. 6 by 8, 48 glasses. Yeah, very important concept. If you double the length, you quadruple the area. So Carrie went back to the drawing board and redesigned the container because the initial sketch did not account for cushioning material between the glasses. Yeah, I was wondering that same thing. Thought maybe she just thought they'd be so tight they wouldn't move around anyway, so it wouldn't matter. The area of the base of the newly designed container is 25% greater than the area of the initial sketch. What is the area in square meters of the base of the newly designed container? Oh. So we just find the area of the base here, and then we multiply by 1.25. That is a really easy last question. So what's 9 times 12? 108. So the area of this new base, the area of the base of the newly designed container, is 25% greater than the area of the base in the initial sketch. This is just a sketch, right? You're not going to fit 3 glasses. Is each glass 3 inches? I guess that's possible. But no, I think we're just saying it was 108 inches. Yeah, they're in square inches. So we're just going to multiply that by 1.25. Because here we're not, if we were increasing the length of them by 25%, we would want to multiply by that squared. But since they already tell us we're changing the area by 25%, we've just got to change the area by 25%. We got to go 108 and multiply by 1.25. Probably could have done that in our heads, but that's 135. And then that's it. I'm feeling kind of unconfident about some of these answers. But let's check through. So we got them pulled up right here. We've got one is B. Oh, here. Let's pause the recording. I said it. So I got this one wrong. But all I did to get this one wrong, let's undo. Let's go back to what we had before. Undo, 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 undo. So look what I did. I didn't pay attention to what the variable represented. So the variable was x, was the length, whereas I used the variable as w. So I just jumped straight to using the variable as w and then assumed that we just use different variables. But no, I needed to do, it's one of my like big tips too, I just forgot to do it, that you've got to go make sure what the variables represent. So x is representing the length. So I did it where x represented the width. So everything I did was correct. Like these final numbers that I got, those should still be correct. It's just that the equation is wrong because I did it with the wrong variable. So what we really should have done here was like kind of starting with similar things. So we should still have this picture, still have this rectangle, but we should have said our length is x. So that's just x. We would still have the thing where the length is the width plus 6, but how we use it then is to say that the width is x minus 6. So then when we talk about the area, we're looking at x times x minus 6 is 432. So it's like if we were solving this entire problem out, I would have gotten the answer correct. If the question asked like what is the length or what are the dimensions of this, I got that correct. But I used a different equation. And that's the thing about multiple choice. You've got to, that matters. The SAT doesn't care that I would have gotten it right. All they care about is that I did get it wrong. So that is 2 on this test that I've gotten wrong. And I haven't checked these answers yet, so let's see. Yeah, 1, 3, and 4, those were all good options here. Of course, you just choose one in real life. See, there are 3 options for the next one. Oh, yeah, and that's what I talked about. I said that, too. That it definitely looks like the correct answer is 5, but I feel like they should accept 4 and 6. And they do accept 4 and 6. What else we got? We had another problem that was like that, too, right? So this was a very clear 15, which they agree with. This was 2.5 or 5 halves for the next one, which is what we put. And then 90 for this one. That wasn't questionable, right? It was the 138 that was questionable. And they were kind about it. They accepted 138 or 137, which of course they should, because it's 137.509. Although that also kind of bugs me, because there is a correct answer there, right? And it's not 137, it's 138. The number 137.509 is closer to 138 than it is to 137. But also, you're supposed to be able to do these problems without a calculator. And they're not supposed to be worried about rounding too much. Like, even in their example. Look how in their example, like, they say that all of these are acceptable. Whereas I honestly think that these should not be acceptable ways to grid this answer. Especially not this one. This is trash. 0.667 is better because you're at least rounding properly. But you should have to do 2/3 there, in my opinion. We're not done yet, though. We got 135 on the last one. Very happy with that. That was strangely easy. And then... Not 48. We got 3 wrong on this? How is this not 38? The length and width of the container base in the initial sketch were doubled. At most... That's my other tip. You've got to make sure you're actually answering the question. I didn't answer the question here. I got it right. I did everything right, but I didn't answer the question. I answered the question, how many containers will the new thing hold? But that's not the question they asked. The question they asked was how many more will they hold? So if right now they hold 12, we want them to hold 48. How many more do they hold? 36. Ooh. That wasn't good. I got 3 questions wrong on that test. What score would that have given me? Can I see that easily here? Maybe not. A whole bunch of charts. Oh, here we go. Why are there so many charts and then it's just number of correct answers? So, oh my gosh, I would have got a... So there's 1, 2, 3. I would have got a 790. That's awful. This was a hard test though, actually. Looking at these, so if you miss, you could miss one and still get an 800, and then if you miss 2 or 3, you got a 790. So it's kind of an easy test, actually. Wait, I'm confused how this is supposed to be graded. Oh, they just have different sections here? Did not all of the problems count? No, I think they all count. 36? Does 36 not count? 36 isn't listed in any of these sections. 36 on the calculator section? Well, it's 36. I got that right. They just, I'm looking at this thing here. Here, I can do this and then drag this over here. So I'm looking at these. I guess this is just listing all the different different sections the problems are in. So interesting, there's no problem solving and statistics, which I did point out on the no calculator part. But then look how like some questions don't have a section that they're in. So going through like number 7 on the no calculator is not anywhere. Number 7 on the no calculator part is not anywhere. I don't get it. But that's the SAT. So I hope that was helpful to everybody. This has been a pretty long thing, but like I said at the beginning, hopefully you skipped around or just paused in between and it took you a while, but hopefully you got through it all. Hopefully it was helpful. If you're taking the test on Wednesday, good luck. Sleep well. Make sure you get some rest beforehand.